Let's now look at preparing our data for machine learning. So our data might be originally available to us as an Excel spreadsheet, for example, and the data may be spread over multiple different sheets in our Excel document. And it might be the case that it has many redundant columns and contains variables that we don't really need. So we might need to specify that we want to learn only on specific columns. And it might well be the case we want to trim out certain columns. There might also be variables that are categorical, and we want to reduce that to a form that's more suitable for machine learning. And we might even want to create new columns and so on. So let's see how to do that using this machine learning assembly method. So under the add data sets, this is where we'll be spending most of our time now. So this is where we'll look at how we can manipulate our data sets. So let's just pull up this set of data, and we click here, Add to Assembly. So when we do that, it brings up this pop-up, and here we can see that we have multiple sheets available. So if you scroll all the way down, you'll see a couple of different tables shown. So there are actually a set of accordions or accordion entries shown here. So these correspond to the 3 sheets in our Excel document. So if you go back to Excel, you can see I've got these 3 sheets here. And now that we've loaded it into the system, you can see they show up as different accordion tabs. So if you open one of those, you'll see the data set here. Unfortunately, it's overrun because we've stuck all this into this floating box here, but you can make out what the columns are. And now we will use this stage to prepare our data. The first thing we'll want to do is choose a source table. So let's just go to Results and set that as our source table. And you'll see, by the way, here the student number has been hashed, obviously to anonymize the data. Now, if we look at some of these columns, we can see, for instance, year and session, and you might find it easier to look down here to see these things, but year and session is probably what we don't want. So we want to trim these out. We don't really plan to do any learning on those variables. So to do that, we go down here where we have the list of all the features in this data set. So as we choose different sets of data, you will find that your list here will change. Your list of features for the data set will change. So we will first uncheck all these selections, which we could do manually as well, but for convenience, there's the uncheck option. And then we don't plan to use the year, so we are considering trimming this out. So year, session, and then we've got too many test results here. So let's just stick to a few tests. So we want to trim these out. And this BMIDX, this is just an index that the system adds to our data. We don't want to learn on that, obviously. So we go ahead and we click here, Trim Features from Data. So you can see that's a shorter list now. And here we have fewer columns. So we've trimmed this down. Once again, you'll want to choose Set as Source Table. So you go ahead here and you choose the sheet of data of interest. And you click Set as Source Data. So you get all the data there. And then you can go ahead and trim out the columns that you don't want to include anymore. So I'll just do that again here. Okay, so that's our data set now. And now what we might want to do is join that to another table of data. So we've looked at the results sheet, but under latent factors, you can see that we have more information about each student. So the first table was one of, well, let's go here to Excel. You can see under the results, this is largely performance data within a single course. and we are interested in learning on or predicting the final exam result, predicting whether the student will eventually pass. So this is performance data. Now if we look under latent factors, this is data about the students themselves. So this tells us things about their high school performance. It tells us about demographic information. It also tells us about their performance in other courses in the academic program. So we want to include this data into our set, but at the moment it's sitting in different sheets here. So to include the student latent information, we need to do a table join. So we do a join using, where are you? Here, a join sheet on column. So we select as our new sheet here the latent factors. So and note that's not going to change our current data set. So we've chosen latent factors for joining, and under latent factors, if we go down, that's also got a column student number. So we do have to choose a particular column from the two tables to join on. So currently we have this table. This is our machine learning set so far. We do have a student number column here, and then in the latent factors we also have a student number column. So we choose for we choose the column under the latent factors here. So we want to join on student number. We want the student numbers to be the same, so that we know we are connecting the right rows together. So it's the same concept as a SQL join, if you're familiar with that. So we just click here, join sheet on column, and now you see you've got a longer list. I can't really scroll to the side here, but if you want your created set of data, you can just click Excel up here, and if you go ahead and open that, then you'll see that that's joined. Right, so you can see here we've got the student number, we've got the 3 tests that we pulled out, and now we've got all this other latent factor information here. So we've successfully joined these 2 tables now, and that might be it. So that's our set of data prepared. Now we can trim out. So again, we can trim out the features that we don't want. So let's uncheck all, and let's trim out this one, and and these as well. And so you can go through and pick out all the features that you don't really want to consider. Let's say we are interested in the dangers of marriage, and so we will include marital status in our data set, and we'll exclude some of these other variables. Okay, so let's just trim that down. So trim features from data. So we've got a slightly more rational set now. And now we want to go ahead and do the machine learning. And it might occur to us, well, we've done all this work to prepare this particular data set, but what if we want to load then the next set of data? So we saw earlier that we chose the 2017 data. So we may be concerned that, well, it's a fair amount of work to go and prepare this data set. But see, what's been happening while we've been clicking around is that all our actions have been recorded here on the side. So this is showing all the commands that we've specified so far to get us to this point. And as we'll see just now, we'll be able to undertake the same actions. We'll be able to run this program on any new file of data. So anyway, what we want to do now is specify our machine learning. So we have to set the label field here because this specifies the output variable. It doesn't make sense for that to be student number, so final exam mark. And then we don't want to train on student number. We do so as our input features. Obviously student number is not a variable we want to use. The test results, yes, we do want to use those. We already choose this for our output variable, so we don't want that to be an input. And then we may choose any of these other variables here. So I'm just going to exclude some of them. Some of these are categorical, and there's a way to handle categorical data, as we'll see just now, but right now I'm just going to exclude those. These are all numerical, and we want to exclude this index. Okay, so that's pretty much ready now. And so we can go ahead and say confirm. So look for the confirm set button. So once you're ready to start your machine learning, you just click on confirm set, and you see it's gone ahead. And don't worry about the NaN for now. That's because it's expecting more than one data set, which we'll add just now. But it's giving us a 95% training. So it's really a very good model that's been produced. And if you look under the results section, you can see some very high accuracies and recalls and so on. You can see in the confusion matrix, the model has got it right most of the time. It hasn't been able to get it right for some of this, but anyway, you can view the actual results there. And there is a separate video for machine learning, but right now we are just going to focus on creating our data sets. So coming back here, we have created the one data set now. Now let's add another data set. So let's load a different year, let's say 2018, and we're going to call this assembly set 2. And we click here, add to assembly. And so the data for 2018, I think it is, we're looking at is shown here. And now we have done all this work in terms of loading up or preparing our data set. So instead of taking the same actions that we saw earlier, we just go ahead and click on run program. And you see now the data set has been prepared here. And it's been prepared in exactly the same way as we did for the earlier data set. One thing that we don't have right just yet is that the labels and the features are also selected correctly. So that will be fixed shortly. But anyway, for now, you just do still have to click this. I actually can't remember which of these I had chosen. But anyway, we can go ahead and click on confirm set, and then that will work out the that will go ahead and do machine learning. So for set 2, it's actually 100% accurate. So the model really works very well for this. It works even better for the second data set, and so yeah, you've got some high accuracies here. Let's see, this we actually saw just now the first set. Let's click on to the second set, and so when the second set loads up, you'll see under the results that we've got here 100% accuracy. Oh, I'm looking in the wrong place. So the boosted results, you can see some very high numbers, not actually 100%, but still a very good model. So anyway, coming back to our result here, what we are seeing here is the persistence of this data set. So for this selection of data, we have a very high accuracy. So for our data set 2, it's a high accuracy. And then what the system has done is it's estimated the accuracy if you use the same models from the second data set to estimate the first model. And so it's still on 90%. So it's quite a good set of models that it's produced here. And then by the same token, if you take the first data set and use that to predict the second data set, you can see almost 80% accuracy. And so this is how we estimate persistence. We consider the persistence to be the how predictive the model that's been developed for one data set, how predictive is that for the other data sets. In this case, we have just 2 data sets, and you can see that the persistence is pretty high. By the way, the values reported here will exclude the training set. So for instance, from ad set 1, we went and trained, and we have an estimate for that. But in a sense, this is not predictive. This is just fitting the same data set to itself. So of more interest is how predictive is it? How much do the models from ad set 1 reflect what's happening in ad set 2? So that's why you'll see 79. It's not the average of these two. If we just average these two, that would be inflating the persistence, which we don't want to do. So this is a conservative estimate. It tells us that the models from the one do reflect the other data sets pretty well. So that's the way we understand the persistence, or that's the way it's defined here. So so that's the first part of preparing your data. So you can you have some of these options. Let's talk about a couple more of them. So if we go back here and we let's just do results here for now. In fact, not results. Let's go back to latent factors. So we've chosen latent factor. And by the way, it's easy if you want to restart. If you've made a mistake or something, then you just say clear the data set, and you choose any other sheet, and you start with that as the source table, and then you go ahead and join and do whatever you like there. Also, if you've made a mistake and you want to clear the program, so you've realized, okay, this step is no good, I need to start that again, then you can just click on clear program, and then that will clear that up. So yeah, and we've talked about these other ones. Now, what we want to do is look at so-called one-hot encoding. So let's first, let's in fact get rid of most of these. So let's only retain categorical data. So marital status, and let's do another one, maybe gender. So let's keep those. Let's trim out the rest. So we click here on trim features from data. And now you see we've got just those 2 categories. And by the way, the vast majority here are unmarried. Yeah, this is okay. So that turned out to be not so useful. Let's pick another one. Let's reload that table. And let's go with gender and race. Okay, so let's trim all the other features out. So we've got gender and race, and we do have males and females in this class, right? It's just because it automatically sorted the data according to the first column. So anyway, let's now go and do one-hot encoding. So that means we want to convert a categorical variable into a numerical variable, and we're going to do this by creating new columns. So all we do is select the columns we want to one-hot encode on. And by the way, I only trimmed it down to these because we wanted to be able to see something of the table. You don't have to trim all the other columns. You can just go ahead and select the columns that you do want to one-hot encode, and then click that. It won't one-hot encode all the other ones if they are not selected. So one-hot encode, we can see now what it's done is for gender, for instance, it's translated our, it's created new columns, is gender female and is gender male. So if you page through the data here, let's look for some males. So here you can see in this column where we've got males, then you can see is gender male is 1 and is gender female is 0. And if you go back, then when it's female, then is gender male is 0 and is gender female is 1. And then for race, in a similar way, you can see for race A, it specifies a 1 here, and for race I, it specifies a 0. And if it is of race I, then is race I is 1 and is race A is 0. So that's how you convert categorical data into numerical data, and this is still categorical, by the way. It's just that it's now in this easier to work with form for machine learning. So you can indeed do machine learning on categorical data as well. So that was one hot encoding. And then there's this other interesting thing here called add feature. So if we want to add some other data, okay, let's work with this. So let's say we wanted to produce a new column. Let's just call our new column Z, and we wanted to calculate a new column given the values in the other columns. So what we do is we specify the new name here, and then we create a function. I'm just going to bump this up. So let's have a look at this function. So we create a function which is going to use the attributes of each row. And so let's just use, for instance, this one. Okay, let's use this one because we do have different numbers on the page here. So is race A. So the attribute we want to use now is race A. And so, and of course, this doesn't mean anything. It's when we are saying 2 times that plus 1. So if it is race A, then it's 0 plus 1, which is 0. And then if it's 1, it's 2 times 1, which 2 times 1 plus 1, which is 3. So let's see what this does. So let's just click. So we calculate a new value and we return it. So that's how our program works, right? So let's say add feature, and now we can see a new column here. So if your race is 0, it gets calculated to be 1. If it's 1, then it's 2 times 1 plus 1, which is 3. So you see it has created a new column correctly for us. So this really opens up the possibilities in terms of preparing our data set. Of course, this function could be quite nonlinear, and so we can create new features, because it might be that we know that by transforming our data, sometimes nonlinearly, then we are able to develop even better machine learning models. So that's another option. You can create new features. And that's pretty much it, right? Adding new features, the ability to deal with categorical data, all of that is possible here, and all that is also stored in your program here. So you can be as complicated as you like, and you can still have that program available to operate on other data sets as well. Okay, so I hope you find that quite useful in creating your data set for machine learning, and please go ahead and watch the other machine learning videos to understand how to actually do the learning part of it, and work with your the various models that are available in the system.